For number 1, what do we got? What's our answer? Yeah. Good. 24x to the 5th. You're multiplying 6 times 4, and then you're adding those exponents. Excellent. Number 2. Camilla? Good. 5 cubed to the 6th. Remember, those are 2 separate pieces, so you have to raise the 5 to the 3rd power. If you had this or 125 p to the 6th, either one is acceptable. Okay? And number 3, Liam? Excellent. A to the 7th, b to the 8th, negative exponent to make it positive goes to the denominator. Okay? How about number 4? Finn? 1. This whole thing is raised to the 0 exponent, so it's 1. How about number 5? Yeah. Excellent. The only thing that is moving is whatever the exponent is touching. So 7 stays where it is. To make this a positive exponent, goes to the denominator. Okay. Now 6, 7, and 8 are our rational exponents. That was a new thing, right? What do we get for number 6? Camilla? Good, because we are multiplying. When we're multiplying fractions, we just multiply across. So 6x to the 2/4, which reduces to the 1/2. When you're multiplying, you don't need a common denominator. You just multiply across. Right? However, when you are adding and subtracting, you need a common denominator. So if you see 9 to the 1st, before I'm able to subtract, what do I need to do? Kennedy? Good. Change it to 9, 5/5, 3/5. Now I'm able to subtract. 5 minus 3 gives us 2. Denominator stays the same. Okay? How about number 8? Yeah, Stefan. Perfect. Good. So again, 2 separate. You're raising them both to the 1/3. So 3 to the 1/3, 6/3, 3 to the 1/3, p squared. Excellent. Good. Okay, that was just a recap of our exponent properties as well as our rational exponent properties. Yes, Camille. Like 6/3 or 5 to the 3rd, you mean? You should. So those, if you had 5 to the 6th, let's just say, and no calculator, no, I wouldn't expect you to. But 5 cubed, we should know. 4 cubed, 4 squared. So those basic ones we should know. But if you, this would be a non-calculator section. Okay? Yes, Finn? You would not. Nope. The reason is they are attached with an exponent. If it was just 9/9, yeah. But because one of them at least has this exponent, you cannot. Nope. Okay. Yep. You can't. That's as far as you can go. Okay. All right. On the homework, on page 11, were there any questions? Camilla? 17. Sure. So 17. Before you take care of that cubed, simplify whatever's inside the parentheses first. Okay? So you look at your numbers, your x's, then your y's. 4/16 reduces to what? Anybody? Good. 1/4. Okay. Now our x's we are subtracting. So x to the 5th divided by x is what? Yep. X to the 4th. Then y to the 1st over y to the 4th is y cubed. Then I would raise it to the 3rd power. So that means every piece, the 1 cubed is just 1, but x to the 4th, 4, and y cubed should be raised to the 3rd power. So we are multiplying our exponents here. So x to the 12th, 4 cubed, and then y to the 9th. You would still get the same answer if you did 4 cubed, x to the 15th, y cubed, 16 cubed, x cubed, y to the 12th. But you're just simplifying more at the end. Okay? Any other questions on page 11? Yeah. 37. Same thing with 37. You look to see if you could simplify anywhere else inside the parentheses first. Okay, before you take care of that negative exponent. So we have negative 7/3 you can't do anything with. Now we look at our a's. When you subtract, you have a on the bottom, b on the bottom, and then c cubed, right? So then everything raised to the negative 4th. Yeah.
So if it's c to the 0, if it only equals 1, would you do like nothing?
Nothing. You would just, I automatically just cancel that guy out because it means nothing. Okay? Then from here, you're raising everything to the negative 4th. Okay? All those negative exponents we have to get rid of. So this whole denominator is going to go to the top and this one in the bottom. Okay? And I have it in parentheses, especially for the negative 7, because you have to raise the negative 1 to the 4th as well. Okay? All right. Because anytime you are raising a negative number to an even exponent, it should be positive. So a lot of cases that I've seen, we put in our calculator this, and it's just carrying over that negative and then the value. So anytime you're raising a negative number, you want to include parentheses around it. Okay. Any other questions? Yep. Okay. So remember, all together through multiplication. So you're raising all 3 pieces to the 5th. So 2 to the 5th, 1/5 times 5 is just x. Then we have y, 15 over 5, which we get 32x y cubed. Okay. And 2 to the 5th is another one we should know as well. All right. So in our notes, if you turn to, I believe it's page 5. If you turn to page 5. Skip right down to the bottom. Okay, so this is where we get familiar with the fractions as exponents. Yes. I was giving you the packet, that's why, before. I asked if you printed the whole thing. Here you go. Yeah. Okay, so anytime you see the square root of 49 or the square root of some number, it is rewritten as 49, and in this box, to the 1/2. Okay? Square root is represented by 1/2. Okay? So, what is the square root of 49? Yep. 7. Okay. Then, if we see the 4th root of 16, we would rewrite that as 16 to the 1/4, and we'll explain in a second. What is the 4th root of 16? Anybody know? No? No? It's okay. Thank you for guessing. Yeah? 2. Okay, the 4th root of 16 is 2. Because think back, when we would simplify square roots, we would look for how many of a kind for square roots? 2. Now with 4th roots, cube roots, whatever it may be, the number in the root, that is called our index. Okay? If our index changes, and for square roots, it's assumed that they really don't put the 2 there, okay? Just like this. So anytime we have a different root, that's how many of a kind you're looking for. So think about it. 16 is 4 and 4, then 2 and 2. Since this is the 4th root of 16, I'm looking for 4 of a kind, and just take 1 out, okay? The same thing with cube roots. So if I have the cube root of 8, that could be written as 8 to the 1/3. What is the cube root of 8? Finn? 2. Cube root of 8 is 2. Because now we're looking for how many of a kind? 3. So if I broke this up, 4 and 2, 2 and 2, I have 3 of a kind, and take 1 out. Okay? So we'll be writing from radical form to rational exponent form. So the first one is done for you. The square root of a can be written as a to the 1/2. The square root of 16 can be rewritten as 16 to the 1/2. Okay? Then the cube root of a, how would I rewrite it in rational exponent form? Hannah? A to the 1/3. Then the cube root of 16, how would I write it? Yeah. Finn? Yep. We're going to see it right here. Okay? So the 4th root of a, how would I rewrite it as rational exponents? How would I rewrite it? Nick? A to the 1/4. The 4th root of 16, how would I rewrite it? Everett? It would be 16 to the 1/4.
Sorry.
It's okay. Okay.
I was talking about the next problem.
Okay. So, when you have 1, 2, and 3, they all have an exponent of 1. However, in this 4th example, we now have an exponent of what? 3. So, any ideas of how I would write that? A to what power? Liam? Excellent. A to the 3/4. So, your index is still your denominator, okay? Your exponent is your numerator, okay? So if I had the 4th root of 16 cubed, how would I write it? Hannah? Good. 16 to the 3/4. So this idea is just rewriting between both forms. And if you notice, the last two are very similar. They're exactly the same thing, just written differently. One has parentheses and one doesn't. However, they both are going to have the same exponent. So we have the nth root of a to the n. What would my exponent be? Mia? did A mn. Would it be the same thing for this one? Yeah, it would. So I like it a lot of the times written this way. The reason is I take care of my radical first, then my exponent when we get to evaluating. But this is another way you could write it as well without parentheses. So this would be the same exact thing. Okay? Same thing with 16 mn. Same exact thing. So these two are exactly the same. One shows parentheses, one does not. Okay? So why we're doing this? Well, now we have to simplify using rational exponents. First, we're going to recall radicals. Okay? So here we have the fifth root of 32. We're going to simplify that first, then take care of the exponent. So, fifth root of 32. What are two factors of 32? Good. What was it? Okay. Can I keep going? Okay. Now, since it's the fifth root, how many of a kind am I looking for? 5. Okay. 4 and 4. And you guys will get to know these very quickly. Okay. Do I have 5 of a kind? 1, 2, 3, 4, 5. So the fifth root of 32 is what? 2. Then I'm taking 2 squared, which is what? 4. So what just happened? Okay, what just happened? I simplified the fifth root of 32. We got 2, but we have this exponent on the outside. So we take our result. If you notice, the radical disappears because we had 5 of a kind. The fifth root of 32 is 2. Then I have to square it, which gives me 4 as my final answer. Okay, let's try a few more. You guys will get to know this. All right, so cube root of 27. Anyone know that off the bat? 3, good. We have 9 and 3, then 3 and 3, looking for 3 of a kind. So the cube root of 27 is 3. Now I have to raise it to the 4th power, which is what? 81. Excellent. Yep. I have 5 of a kind. Yeah. Then you can't simplify it as stay as this. Okay? So now, if we look at the 6th root of 4 cubed, this is written a different way. Okay? I'm going to show you 2 different ways. 4 cubed, how many 4s do we have? Then if it's cubed. 3. Okay? So if I expand this out, 4 times 4 times 4. How many of a kind am I looking for? 6. Okay? Do I have 6 2s? Yeah. Okay. So this equals 2. We took care of that exponent already. Now, if I wanted to rewrite it as a rational exponent, so rewrite it with a fraction as an exponent, what would it be? 4 to what power? Hannah? Not 1/6. It's okay. It's fine. How'd you get it? What was it before that? Good. So 4 to the 3/6 is how I would rewrite it, which is correct. 3/6 reduces to 1/2. Now 1/2 as a radical is what? Hannah? Reset it. Square root, right? It's the square root. What's the square root of 4? Is that the same thing what we got here? Yeah. So that is just two different ways I showed you, right? You guys figure that out. By rewriting it as a rational exponent, sometimes you could reduce it to get a root that you know of. Yeah, Hannah. Yes. So I rewrote it as a rational exponent and then reduced it and then wrote it back to a square root. Okay? All right. So now let's confirm our answers by writing as a rational exponent. So the fifth root of 32 squared, how would I write that as a rational exponent? 32 to what power? 2/5. Now if I see this, this means the fifth root of 32 squared, which is 4. Okay, hold on 1 second. To the 4/3, which equaled 81. Now you can write number 3 bunch of different ways, right? 4 to what power? We actually did this already. 3/6, which reduces to 1/2, which equaled 2. Good. Give me 1 second, you guys. All right. So the first one to rewrite, good. 8 to the 2/3, excellent. For number 4, number 2, 6 to the 4/3. Number 3, 7 to the 5/4. Number 4, 3 to the 8/5. Excellent. 1 through 4, perfect. Now rewriting using radical notation. So we have the 4th root of 5, excellent. The square root of 7, what's one thing that we have to include? Yep. 3, either this way, and the square root of 7 cubed. Either way, do not forget about that exponent. Then the last one, 7th root of 16 to the 6th. Excellent. Any questions about rewriting? Okay. Now if we look at the bottom of the page, okay, we are going to rewrite, then solve. Okay? We're going to rewrite, then solve. So, how would I rewrite 8 to the 4/3? How would I rewrite that? What's my root and what's my exponent? Hannah? Perfect. The cube root of 8. Okay, so your root is your denominator, your exponent is your numerator. So the cube root of 8 is what? 2. And 2 to the 4th? 2 times 2 times 2 times 2. Nick? 16. Good. Okay, so that's what we're doing to, yes. So we could evaluate my root first before raising it to the 4th power. That's PEMDAS. So parentheses first, then your exponent. Okay? Yeah, Liam. Either or. Either or. I could have wrote this a different way. Here has parentheses. Here does not. Or that way. Okay, it means the same thing. When we do evaluating though, or solving, you want to focus on something small. Then raising 8 to the 4th power first. Okay, so you want to take care of your parentheses first. Number 2, what could we do first here? We have 64 to the 4th 6. Can that be simplified? Yeah. Okay, so if we have 64 to the 2/3, how would I rewrite that? All I did is we reduced the fraction. Yeah, Hannah. Hmm. Correct. You could do it that way given the original, right? So I'll do it both ways for you. 6th root of 64 to the 4th, or if I reduce it, 64, cube root of 64 squared. Okay? Now, the 6th root of 64, how many are you looking for? 6. Cube root of 64, how many are you looking for? 3. So I want you to do this both ways. To see, you should arrive at the same exact answer. Okay? So write these both down. The first one was non-simplified fraction. The second one was. And go ahead and solve. Right. So we should have gotten 16 for an answer, both ways. Okay. The first way, the 6th root of 64, you're looking for 6 of a kind, which was 2. Then 2 to the 4th is 16. Okay. If you did the cube root of 64, you're looking for 3 of a kind. Well, there's 2 sets. For every group of 3, one comes out. For every group of 3, another comes out. 2 times 2 is 4. 4 squared is 16. So you should have gotten the same exact answer. How many of you did? Good. Okay. Try 3 and 4. Number 3, how do I rewrite it? Hannah. Good. Okay. So, what is the square root of 100? Nick? 10. And then 10 cubed? Go ahead. 1,000. Good. Excellent. All right. How would I rewrite number 4? Everett? Good. The 5th root of 32 to the 4th. Okay. The only thing is square root is when there's a 2 in the denominator. 3 has the cube root. 4 and above is 4th root, 5th root, 6th root, 7th root, so on and so forth. What is the 5th root of 32? 2. Then 2 to the 4th? 16. Good. Excellent. How many of you did get both of those correct? Good. Let's see what it says. All right, so now we're going to try some practice. All right, just some terminology to remember. Okay, the base in exponent form is A. Okay. The exponent in radical form is M. Okay, so that is your numerator. The index is your N. Okay, so N is your denominator, exponent is your numerator. Okay, the index of a radical is always the denominator. Okay, some key terms there. All right, so I want you to go ahead and try 1 through 6. Okay, 1 through 6 through these. Okay, for the first one, it's the square root of 9 cubed, which is 27. Awesome. Okay, number 2, the square root of 36, which is 6. 6 cubed is 216. Awesome. Then number 3, the 4th root of 16, which is 2. However, it's 2 to the negative first. Can't have a negative exponent. It ends up being 1/2. Awesome. Any questions on 1 through 3? Yep. Okay, number 3, it's the 4th root of 16. We're looking for 4 of a kind. So if we break it down, 4 and 4, and as you know, I cross out as we go. Okay, 4 of a kind is 2. 2 to the negative first. I can't have a negative exponent, so that is not negative 2. Okay? Negative exponent just means it goes to the denominator. Okay? Number 4, the cube root of 8, correct, is 2. 2 to the fourth is 16. Number 5. Finn? Nope. Fraction form. Okay? All right. So, for number 5, the 6th root of 64 to the 5th. We're looking for 6 of a kind. What is the 6th root of 64? 2. Then 2 to the 5th. God bless you. Is 32. Okay? Then the last one is the square root of 49, which is just 7. Awesome. Okay? Any questions on those? Okay. One last thing, if you take out your calculators. Okay, just briefly, we really won't need this unless you get stuck, but all of this 1 through 6 would be a non-calc type, okay, on your test or quiz, okay? But if you get stuck and you're doing practice, or when we get to solving, you could use your calculator, okay? So, 6th root of 50. There's no 6th root of 50, so we know it's going to be some sort of decimal. So in your calculators, there is a tool. I'm going to show you 3 different ways, okay? For the 6th root, or a number other than the square root or cube root, go into the math key, which is below alpha. And number 5, see where it says the X there? That's where you could change the root. So if you press number 5, and then type in 6, press the right arrow, 50, you get a decimal, okay, which is correct. There's no 6th root of 50. So you could also do, if you type in 6, then go to math, number 5, it goes already to the exponent, to the index. Those of you with the older calculators, if you see 6, and then it doesn't move it to the index, that's okay. It's still taking the 6th root. Because I know some of the older calculators still do that. Okay? So here, you do 50. Okay? But sometimes when I'm, going through these types of problems, writing a different root takes too long. So what's another way I could write the 6th root of 50? 50 to what power? Yeah? Excellent. So 50, the little caret here, 1, 6. And I get the same answer. Okay? All right. The second way is type in 6, math, number 5, type in 50, that way. Okay? So the same thing applies. For B, it's the cube root of negative 29. Do you think we will get an answer? Check it out. See if we do. Did we get an answer? Careful. Make sure it's the cube root. What do we got? Right. So that's strange because didn't we, for square roots, were we able to take a square root of a negative number? No, because what would we get? Anyone remember? We would get an imaginary solution. So this is one tool when you're taking an odd root of a negative number. So if I go to math and press number 4, because that's the cube root, of negative 29, I will get a negative answer. Odd roots of negative numbers are okay. You will get a negative answer. The negative just comes out, okay? However, you cannot take an even root of a negative number. Yes? No. for this, you would not. Okay? You would get a negative answer. The last two, 3 raised to, and the caret is where you raise to your exponent, the 1/4. Enter. That's what you get. And then 341 raised to the 2/5. This is what you get. Okay? So, again, for D, that's the 5th root of 341 squared. This is what it would look like if I did this in radical form. 5th root one way. Oops. Enter. Or if I did 5th root 5, 341 squared. Get the same answer. Okay? So when in doubt, you have your calculators to help. However, the next chart will become your best friend. Okay? These are the perfect roots to remember. Okay? All of your square roots. Okay? All of your square roots are this first column. So these are your perfect squares in this first column here. So that means 2 squared, 3 squared, 4 squared, 5 squared. Okay? So when I take the square root, remember the denominator is 2, square root of 4 is 2, square root of 9 is 3. Okay? Those are your perfect square roots. The next column are your perfect cube roots. This is important to remember. These are your perfect cube roots. So that means when I take the cube root of 8, I'm going to get 2. 2 cubed equals 8. Cube root of 27. 3 cubed gives me 27. So see how they're connected. So the last 2 columns are the perfect 4th root and 5th root. So the 4th root of 16 is 2. So that means 2 to what power gives me 16? 4. 3 to the 4th gives me 81. Okay, so that's how they're interchangeable. Okay, so there's going to be times, if you notice here, that we don't really rewrite it in radical form. Okay, so I want you guys to always write it in radical form. It's easier to remember than doing, say if I rewrote 25 with a smaller base. If I rewrote 25 as 5 squared and did it this way, I would still end up with the same answer. But that's why you should know your perfect roots to go back and forth. Okay? So, if we look at number 5 together before you guys get into practice. If we look at number 5, 1 over 64 to the 2/3. How would I rewrite it? In radical form. Hannah? Perfect. So, now, looking at a fraction like that with a radical over the entire thing, the radical properties state if it's the same root, I could separate it. Okay? What is the cube root of 1? 1. What is the cube root of 64? What is the cube root of 64? 4. Then I'm squaring it. So that means it's 1 squared and 4 squared, which is what? So if you see a radical over an entire fraction, it could be split up, okay? Cube root of 1 over cube root of 4, simplify it, then square it, okay? So we're going to go through some practice, okay? 1 through 8, finish this page. We are going to go through it together to make sure everyone is good, okay? If you get stuck, you have people around you, okay? You can work with a partner going through 1 through 8. I'm going to give you about 10 minutes, okay? 1 through 8. Go ahead. And if you're done, let me know. Okay, let's go through these. For number 1, good job. It's the cube root of 27 squared. Cube root of 27 is 3. 3 squared is 9. Good job. Number 2, it's the square root of 25, which is 5. 5 to the negative first is 1/5. Awesome. Number 3, the square root of 49 is 7. 7 cubed is 343. Excellent. 1, 2, and 3. Any questions? Okay. Number 4 should be what? Yeah. 1/4. You have the 5th root of 32 to the negative second. 5th root of 32 is 2. Now we have the negative exponent. Does not mean we multiply those two together. Negative exponent means it goes to the bottom. Then we take 1 over, 2 squared is 1/4. Okay? Number 5 we did on the board. Number 6, good job, 5/3. You take the cube root of 27 over the cube root of 125, then eventually to the negative first. 3/5, negative first, 3 to the negative first, 5 to the negative first, negative exponents. Whatever's in the bottom goes to the top. Whatever's in the top goes to the bottom. Excellent. Number 7. What do we have? Yeah. 27 is correct. Okay, same thing here. 4th root of 1 over the 4th root of 81. Then eventually to the negative third. 4th root of 1 is 1. 4th root of 81 is 3 to the negative third. 1 to the negative third. 3 to the negative third. Negative exponents. Okay, 3 cubed. 27 over 1, which is just 27. Okay, then number 8. What do we have for an answer? Mia? 125. Same thing. Square root 1 over 25 eventually to the negative third. Square root of 1, square root of 25. Square root of 1 is 1. Square root of 25 is 5. Both go to the negative exponent. Cannot have negative exponents, so they switch spots. Since they're both negative, you end up with 125. Okay? Any questions on those? Yep, Rory. Mm-hmm. Because it's 2 to the negative second. Not a fraction like this. Okay? So it's 2 to the negative second, therefore just the 2 moves. Okay? Any other questions? Okay. Your classwork and homework, okay, whatever you don't finish, starting on page 9, it's pages 9 and 10, 1 through 28. Okay, it's a little bit of everything. It's rewriting from radical to rational exponents, then rational exponents to radical form, then exponent properties, and then evaluating without a calculator. Okay, so pages 9 and 10. Okay, pages 9 and 10, 1 through 28, I believe. 1 through 28, yes. Okay, 1 through 28. Okay, and those of you that will be taking the SATs on Wednesday, okay, and or Friday, the lessons will be recorded. Okay, Wednesday we might do a little more practice on this and then start solving. Okay, but Wednesday and Friday we're finishing up 5-2, starting 5-3, and then Friday's 5-3. Yes.
Like on a calculator, like it gives me a decimal instead of a fraction.
Then you do math frac. Okay, math frac. But again, these are all non-calc sections. Yeah. Yep. Okay, so try your best to do it without a calculator, and then you could check it in the calculator. But math frac is where we go.